Welcome to aminacademy.com. Let us do life stories of scientists. In that, we discuss about the Ptolemy. Ptolemy was an Egyptian astronomer, mathematician, and geographer of Greek descent who flourished in Alexandria during the 2nd century CE. In several fields, his writings represent the culminating achievements of Greco-Roman science, particularly his geocentric, earth-centered model of the universe, now known as the Ptolemaic system. Virtually nothing is known about Ptolemy's life except what can be inferred from his writings. His first major astronomical work, the Almagest, was completed about 150 CE and contains reports of astronomical observations that Ptolemy had made over the preceding quarter of a century. The size and content of his subsequent literary production suggests that he lived until about 170 CE. We will discuss further about the story of Ptolemy. Claudius Ptolemy from 100 CE to 170 CE was an Alexandrian mathematician, astronomer, and geographer. His works survived antiquity and the Middle Age intact, and his theories, particularly on a geocentric model of the universe with the planets of following orbits within orbits, were hugely influential until they were replaced by the heliocentric model of the universe proposed by Copernicus and Galileo. Life and work. Ptolemy work was found their way from the ancient Mediterranean to the Islamic world, translated into Arabic in the 9th century, the Byzantine Empire, and then back to Europe in the Middle Ages, translated into Latin in the 12th century. The Almagest was the first issued using the printing press in 1515. Ptolemy's theories were only seriously challenged and then replaced in the 17th century during the scientific revolution. What is that Almagest? The Almagest is Ptolemy's most famous work and was likely completed in around 150 CE. It is a sort of textbook consisting of 13 volumes which cover his own theories and plenty of ideas of earlier thinkers regarding the movement of the sun, moon, stars, and planets. He extended the ideas of Almagest in his planetary hypotheses. It was crucial for most thinkers to have the Earth as the center of the universe because of the importance they gave humanity in the cosmos. Ptolemy was a keen astronomer, although he was a reliant on the naked eye since the telescope was not invented until the early 17th century. What Ptolemy did have access to were masses of astronomical observations taken by ancient Babylonian scientists from the 8th to the 3rd centuries BCE. This is a Ptolemaic model of universe. The Ptolemy's model of the universe, where Earth was considered the center of the cosmos, with the sun, moon, planets, and stars revolving around it in uniform circular orbits as they travel through the substances labeled ether. It was crucial for most thinkers to have the Earth as the center of the universe because of the importance they give humanity in their view of the cosmos. In Ptolemaic astronomy, after the central Earth, there is in order to the moon, Mercury, Venus, the sun, Mars, Jupiter, Saturn, and then the stars. Ptolemy attempts to measure the motion of the heavenly bodies, and by doing so in complex tables, it is possible to predict their future movements and both solar and lunar eclipses. One of the problems Ptolemy and his predecessors had was that it is possible to observe that the heavenly bodies do not move in regular circles or at a regular speed compared to the Earth. A theory was developed to explain these facts, namely that a body like the moon traveled in a smaller perfect circle, an epicycle, that itself follow the track of the larger circle, the different, which revolves around the Earth. For the Sun, the orbit is slightly off center compared to the fixed central point, the equant. And so, as the Sun moves around the Earth, it appears to move closer and then further away when actually it is still following a perfect circle. Epicycles also explain why the planets can be observed to move backward for a short time, their retrograde motion. It is here important to remember that it was Ptolemy's mathematical tables and catalog for information on the stars which were considered most useful by contemporary and later astronomers. Ptolemy's theories as to why or how heavenly bodies moved free for less relevant than the measured observation of their movements. This is just as well because although Ptolemy's theories fit the observable facts, also, alas, they were entirely wrong in many cases. Even more significantly, the errors were adopted as gospel by just about everyone, including the Christian church, which rather liked the idea that God's creation, the earth, was at the very center of things. To challenge Ptolemy and Aristotle's view of the cosmos because became nothing short of heresy. There was another consequence of the dominance of Ptolemy's idea, and this was the loss of all earlier works on similar topics. In later works, notably Tetrabiblos, Ptolemy presents a theory that the movement of the celestial bodies have effect on earthly matters, not, for example, the weather, and this can be predicted thanks to astrology. In this harmonies, Ptolemy developed a model where whole numbers and their ratios are equated with the musical scales. Optics discuss how the human eye works. Ptolemy believed the eye sends out cones of perception which strikes the object, and the soul somehow reads this information to determine shape, size, color, and so on. Ptolemy was very interested in cartography and ambitious enough to want to create a world map. Ptolemy's eight-volume geography drew on the work of other geographers, notably Marinus of Tyre. This is a Ptolemy's map of the world. So far, we discussed about shortly about the scientist Ptolemy. We have done. Please subscribe our YouTube channel.